Hey everybody, welcome to chapter 4. We're going to be doing some exploring of data in R. I am using this book for our work by Dr. Gardner. It's excellent. I think it's very straightforward. So just in case you wanted to purchase it, again, you're welcome to, but you don't have to. All right, I'm going to share my screen. Going to our studio. Again, go ahead and make sure you have a Word document open as well, because you're going to want to copy and paste some stuff so I can see what you're doing. I'm going to close my exercises from chapter 3. So when you first open R, it might look like this. Remember, again, you can open it up, add an R script up here. I'm going to click on save. And since it's new, I'm going to type in chapter 4 R exercises. That's just easy for me to remember. I'm going to save it and then it'll be on my computer. Okay, so for this, we actually need to input some data. So you're going to go up here to the right-hand side of your screen in this corner, and you're going to click on Import Dataset. And you're going to click From Excel. Looks like I have to update my stuff, so I can go ahead and click yes, and it's going to do some updating down here on the bottom left-hand side. Okay, so don't be alarmed when this happens because people are always working on R. There's always updates. All right, this is really normal for it to have happen. Okay, so when you click on import a data set, this is I'm going to make my little window close. Okay. This is the window that pops up. All right, so you're going to browse your computer. Your Beetle data should be on Canvas. I put it on there. So I'm going to open up Beetles, the XLS file. Okay. Down here on the bottom, it named it Beetles. I don't want it to say that. I want it to say BD. You want something short. I try to stay away from naming things data because data is also a command and it gets messy. All right. So don't click on anything yet. The next thing you want to do, this will just save you a lot of time, all right, is click over here so that this changes to view BD, and then you want to highlight all of this because you need this library and you need this command, and it's a long command to have to type in, all right? This is the map of where your Beetle data was. If you don't have your Beetle data on the computer because it's still in Canvas, just stop what you're doing, go to Canvas, download the Beetles XLX file, Excel file, okay? Put it on your computer somewhere, like make a file, and then you can upload this. So you can come back, pause me, rewind, come back, all right? Once you've highlighted this, you're gonna click import. So now up in the R script, you'll have a second tab named BD, and it's all the Beetle sizes, all right? So now what I'm going to do is go right back to chapter 4's R script. I'm going to right click and I'm going to paste. Oops, I don't want to paste my YouTube link. Shoot. Well, if you lost yours, that's okay because it's down here in the console. So you can go down here and copy and paste, copy and paste. You're going to have to remove these arrows. Okay, and so now you have library, which is read Excel. Problem is we might have to install a package. So let's install packages. We're going to put our little quotations, and we're going to type in read Excel. All right, just like below, we're going to run it. One or more of the packages are already loaded. Okay, do you want to restart prior to install? Yes, okay, looks like I have to restart. You might have to restart as well. It will automatically save for you, unlike any of you who have taken GIS with me and GIS crashes and is rude. R tends to save as you go, but you still need to do it, okay? All right, so now on the bottom, it says the package read Excel is successfully unpacked. That just means that all the pieces are in there now. So then you wanna make sure that you have the library. So I'm gonna run the library, okay? So now what this is saying, you can also make this a little bit bigger if you want. You can make this a lot of different colors, but we'll mess around with that later. Is that BD, what I named, We're telling it to read that Excel file that it came from here. This is where I stow my stuff. Okay. So I'm going to run that. Okay, good. On the bottom, it's blue. That means yes, it worked. And then view is a command. So you want to view BD. So it's going to take me to my file. So now I can check and make sure nothing weird happened to it. All right. Yay. So you have officially uploaded your work. So you have 25 observations of one variable, right? So the one variable is the column. That's a variable. And each of these rows is an observation. All right. That's how R thinks. All right. I'm just trying to go slow and help you understand how everything's going. If for some reason you don't have this part, you can do a couple different things. You can sit here and type it all in, or you can go back and re-import your data, which would be you just delete this one, then it's not there anymore, and you can go back and import your data set and make sure that you grab the code correctly, which I've done many occasions because it's annoying to have to type it in because inevitably you will miss something and then it'll yell at you and go, it doesn't work. Okay, so just as a heads up. All right, so I'm going to couple pound signs and then put averages in R. So I'm writing myself a note. All right. So first you're going to write BD and you're going to run. And what comes up on the bottom is what's called a tibble. So it's like a tidbit, right, of your data set. So it only shows you the first 10 rows down here, but it shows you the first 10, which is kind of cool. If you want to see all of them, you can, but say you have a data set with like 1,000 rows, you don't want to see 1,000 rows in here. It's nuts. It messes up your stuff. So then you type it in, and now we want to get the mean. All right. So what's the mean? Do you guys remember? The mean is the average, right? Okay. So now we're going to tell it to give us the mean. So mean, oh, there it is. So that's the command. All right. And then it gives you parentheses. So then you're going to put in BD because you want the mean of your data. And then I'm going to click run. Oh, it does not like that. It's mad at me for that. What's my warning down here? Default BD. Okay, so sometimes it gets mad at you. All right, so I'm gonna click save. I'm gonna type in mean again. And I'm gonna put no, it still doesn't like that. Let's see. So this is the fun part with R. Stuff just happens sometimes. Okay. So let me try this. Let me try a different code here. It might be that I don't have the proper package. So let me think about this. Which package is mean in? Averages might be in a different package. So we're going to look at packages. Averages. Okay, I hit enter. Let's see, data sets, mini tabs, data, mass, tibble. All right, so if you get to this point, you click save. I'm going to open up a different screen. So I'm going to stop sharing and reshare just to make sure, okay, because I'm trying to teach you what happens, all right? And this is what I do all the time if I have a little weird code. So I'm going to share. I'm going back to my online format. So over here, come on, go to Google or whatever thing you want, right? Which package in R is used for data visualization? Sure, let's try that. Okay, the RG packet, RGL, is for 3D data. That sounds pretty insane. A lot, right? Which R package should you use? Oh, ggplot, leaflet. Okay, so ggplot I know pretty well, so I'll probably go to that one. But see how I just Googled the question? Okay, you could also, what package in R is used to find the mean? Do that, right? Mean. So in R, the simple mean is calculated using the mean function, and the weight mean can be done that way. Well, it didn't like me very much, right? So we can try it again. Sometimes R is annoying and it's rude, right? So the other thing is, No, go away, go away. The other thing you can use is say you're getting stuck. And I keep getting a warning. So I'm going to go grab the warning message from R. All right, I'm going to copy it. I'm copying it from my console. I don't know if you can see this or not because Zoom is dumb. And I'm going to type it or paste it up here. I'm just pasting the warning message into Google. All right, and I'm going to see what this says. Oh my gosh, this looks so scary. There's all this stuff coming at me. Oh my gosh, oh my gosh. Just relax for a second. All right. This is just part of learning what to deal with. All right. So I'm going to scroll through here. This is no help. So I'm going to go back. It says it receives a weird string or character. So that's the problem. Let's see how to solve argument. Anyways, you can go in here and you can mess around. Okay, go away. Lots of pop-ups. I got to fix this. All right. So now I'm going to stop sharing. I'm going to go back to R again. That's the way you find the answers if I'm not, say, helping you for some reason. So let's try this. Let's change this to an equal sign. And let's run it. Okay. And let's view it. It's all right there. BD. Okay, it's right there. So now I want the mean, the arithmetic mean of BD. Okay, we can also try data equals BD. Okay, data. I'm just playing around with a couple things that I know that might work. Some old code. Nope, doesn't like that either. I don't really understand why it's not working very well. Let's do ggplot install packages. ggplot run library. If we were in class, we'd be doing the same thing, just so you know. All right. I'm trying to teach you just like I'd be sitting there in class yelling at it. There's no library in ggplot. ggplot2. Let's try that one. Install ggplot2. Yep, that's the one I want. Okay, so go ahead and install ggplot2 and then run the library. And now let's try mean. See, look at that. You just had to put in something good. Mean BD. Hopefully run. Oh, it's not numerical or logical, so it doesn't really oh, size. That's why. Okay, so instead of it being BD, we're gonna have to run size. All right, and you have to spell it capital SIZE. I apologize for messing around for so long. All right, so we want the mean of BD money mark. Okay, so what's that is telling us is grab the data from the BD file, and then the little money sign says which column to grab it from. And there's only one, but sometimes you'll have like a ton of columns. So size. All right, and now I run it. Whew, now it finally gave me the answer. Look at that. Dr. Horn is slow on the go sometimes too. Okay. All right. Now we have mean. What about median? Let's do median. Oops, nope, I don't want to type in down there. I want to work in our up at the script. Median. Okay, so median. BD. Money sign. Size. Run. Okay, the median is also 26. Let's do mode. Even though we don't use it that much, we'll try anyway. Mode, BD, money sign, size. Oh, error. Sure. We can restart R. Fine, whatever. Go ahead. Install your packages. So I haven't used R on this computer before, so it doesn't have all my fun background stuff. So your computer might be doing the same thing. Hopefully that's good. So you can see I'm not freaking out. I'm just going through the motions. All right. Let's try using a daunting formula. I don't know why we would try this, but let's do it anyway. As numeric names which dot max table BD, and then you should have 4 parentheses, 1, 2, 3, 4. What the heck is this going to do? 26. So see, we used to have to type in all this BS right here, right? But now some nice people have worked on this. You can just type in mean, median, and mode. Pretty awesome, right? Okay, save. So you've learned how to install a package, or you've learned how to, upload your data, right? We uploaded a data set. You know how to install a package. When you install it, it has to be in quotations. Then you have to grab the library, which does not have to be in quotations. All right. This is just to grab the file from the right place, this highlighted section here. So what you can do is like, maybe I want to make myself some notes. So I'm going to hit enter and make, oops, go back. Oh, is there a go back button? I can't remember. Shoot. Dang it. I thought there was. Rerun the previous code. Did they take it out of here? Oh no, that's lame. There used to be a go back button, like if you kind of messed up like I just did. Okay, well, I can scroll back through my console and find it, which is right here. Thank goodness. Do I have library read Excel? So I just need BD equals this right here. So that's why it's nice to have your console open, but it will also go away. So, all right, so paste. So there's my code. So I'm gonna remind myself by putting some pound signs, and I'm gonna, this is the pathway for our to find my data file. Okay, and this just kind of reminds myself what that's for. Does that make sense? So if you want to write yourself notes in R, this is how you do it. You can also do it at the end of a code. So I'm going to hit pound, 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 and I'm going to write, this is the code for finding the mean. Okay. And then, okay, everything is the same except for my spelling. So awesome. And I can just paste it and I can write, here, I don't know what feign is. Can't type very well. And this is for the median, right? And this is for the mode. So then I copy, paste, and I write mode on here. I highly recommend, and I'm going to do this one. This was too long. Don't use, right? I highly recommend writing yourself some notes. I have done this. I learned finally how to do this properly, and it helps a lot, especially if you are working on something and you have to stop and go back later, or like I'm rerunning some data from when I was in grad school, and thank goodness I made notes because otherwise I don't know what the heck any of that stuff is. All right. So we don't usually have to use mode, which is fine, so don't worry about that. Let's go ahead and make a table. So let's type in table. And is it going to let me do it? Table. All right, now you can do VD. All right, and run. And now it gives you a little table down here. And so what does that table probably look like? From the lecture that hopefully you watched already, you can see that there's a number under each of the measurements or the size. So it's probably how many times it happens. So if you wanted to figure out what the mode was, because the mode is what? Something that repeats the most of itself, it looks like it would be 26 because there's 4 measurements of 26, right? You remember that? I just want you all to kind of have those things in your head. You don't have to remember it completely, but so it splits the data for you. You can also work out the mean from the sum of the number of items. So let's try this. Sum BD divided by length BD. All right, let's try that one. Okay, so 650. So the sum of all of these divided by the length of all of them. Interesting, right? So the length command is like the count function in Excel. where you can join the sum and the length commands together. You can try them separately and see if it gives you the same result if you want. So you can do sum BD and hit run. What is that? So that's 650, and then length. Just gotta spell it right or it won't work. BD, can run that one. So 650 divided by 1. So that is correct. See how that works? Click save so you don't lose your gear. All right, we can run our data with multiple samples, and it's a little bit more complicated, right? So when you're running it with just one data set, it's not a big deal, but when you have multiple data sets, it's a little tricky. All right, so now you're going to need the hog data, the hog flower data. So let's see. I'm going to pause really quick because I can't remember if I gave this to you, so I'm going to upload it into Canvas. Okay, I found it. It's on Canvas. It's called hog louse. It's a type of flower. I'm going to share my screen again. Going back to our studio. All right, so we're back here in our studio. And in order for me to use a data set, I have to import it, right? So I'm going to go up here to the right. I'm going to click Import Data Set from Excel. I'm going to browse my computer. I have mine in this stats file here. I'm going to scroll through and find Hoglouse. This is on Canvas for you. Okay. So now you have 4 cool columns, right? So you have 7 observations and 3 different locations, it looks like. So we are going to name this HOG 3. So it's just a little bit shorter, okay? You just have to be careful with some of your names so that it doesn't ever overlap with a function. So always just think about that. So then I'm going to click over here, changed it over. I'm going to copy this, click import. I'm going to go back to my chapter 4 exercises. I'm going to put hoglouse data, start here, just so it's different. And I'm going to paste. All right, so I'm going to run, make sure we know that it's hog and view. Okay, so that means that it's in now. Let's click save. Everybody got that? If you need to pause me, you can. There are no quizzes in these tutorials. So pause, rewind, whatever you need to do. Freeze the page. Okay, so we have the data in here now. Let's see. We need to work on how to deal with what's called NA. So in the hog data, you can see that there's 4 spaces where there's no numbers. And so each of these are columns that represent the abundance of freshwater hog louse at these 3 different sites, upper, mid, and lower. Some of the data is the NA. So unlike in Excel, R really hates empty cells, like it gets real mad, okay? And so you have to give them a special assignment. So you think of NA as not available. So we need to know how to deal with them because they might be real missing values. Or as in this case, there just might not be any lengths for those, right? Because there weren't any. So we're going to look at this and play around with it, okay? All right, so there should be one more set. Hang on just a second. All right, fixed it. So back into R. Sorry for all the popping in and out, but I have to add data as we go, and this is what you will be doing. So I'm trying to do it just like you are going to have to do so that if I run into issues, hopefully I can resolve them and help you do it. All right, we're going to import another data set from Excel. You're going to browse your computer. Mine is in my stats file. Yours is on Canvas. It's called hog2. Go ahead and grab that one. You can leave it named hog2. You can see that this is a little bit different. There's, counts of things plus site. You can leave this named as hog2. Go ahead and grab this code, import. Now we are going to type in hog2 data workup. You can write whatever you want. I'm just writing myself some notes. Okay, paste. I'm gonna go ahead and run this data. That way it reads my data. There it is. Okay, awesome. So now you should have hog2 data. You can see over here on the right, these are the 3 data sets that you have in R right now. All right, so now we have hog2 data. All right. So this is arranged in a different format. This is what you could be called, or could be called, scientific recording format. Each column here represents a separate variable, and each row is what's called a replicate. All right, it's a single observation, but it's a replicate. This is much more powerful data than this hog3 data, which is just here, okay? This allows us to carry out a lot more complicated statistics when it is laid out like this. So if you've had a class with me before, maybe you haven't, it's really important when you write your data down, it's fine, but when you go to make your Excel sheet, it's really important how you organize it, because that really affects how you can run it in a program like this. So in our example of hog2 data, we have 2 columns, one headed count. It's the response or dependent variable, all right? And the other one is site, and it's the predictor variable, or it's the independent variable, all right? There's no NA here in this hog2 data. You can get the missing values with this kind of layout, but not usually when you just have one predictor variable. You'll need to know how to do both layouts, so we're going to work on this. R has a bunch of different commands, and we're going to go through it now. So back to our script here, I want you to type in COL, capital MEANS. It'll start to pop up for you. Then you're going to put in hog3, and you're going to hit run. All right, down on the bottom, you're going to get a little table, and you can see in hog3, because we have those NA, right? There's 4 observations, upper, mid, and lower. All right, now I want you to write in COL means hog3, comma, NARM, which is how you tell it to remove the NA values, okay? So this is the little code, or the button, right? But you have to write the code for it on how to make it leave that alone. So click that, it gives you an equal sign, and then I type in true in all capitals. And so that's going to have it remove anything with an NA. If I wanted to keep the NA values, which I don't ever, I would write false. But this is how you write the code for things, all right? So now I'm going to click run. Now that gives us the real means for the upper, mid, and lower values. Does that make more sense? Because otherwise this mid and lower, just because there's an NA, you don't get a mean. It's just how R works. All right, go ahead and click save. So then let's go to our next page here. I'm going to have a Word document for you that's going to have a whole bunch of commands written down. There's also lots of cheat sheets online for doing different things. I just had to run a new data program thing that I hadn't done before. So I typed in, how do I do this in R? And there's a whole bunch of code, a whole bunch of instructions. That's the cool part about R, is even though people are like, oh, it's really scary, it's also free. And folks are working on it all the time. So there's tons of help out there. So you don't have to buy it. You don't have to worry about paying for it's out there. So just something to think about. Okay. So we had the NA items removed. And let's go ahead and do this also in the other data set. Sorry, I'm reading and talking at the same time. So now we're going to use the apply command. All right. So we're going to write apply. It'll pop up for you. Cool. Oops. Apply. You're going to write hog3 because that's our data set. You're going to leave the word margin. We're going to do margin equals 2. Then you're going to go past the comma and you're going to write FUN Okay, I know this seems weird, just it's a function, okay? So fun isn't let's go have fun. Fun is a function. So just like when you tell Excel to do a function, like sum equals something like that, this is how you tell R. So fun equals median, comma, and then na.rm. So please remove these things, right? Equals true. True. Now, that doesn't look quite right, so I want to make sure. Yep, so R is mad at me. So over here on the left, there's an X. It means that something's not right. So I need to get rid of these red dots. All right, and now my code is good. So now I go ahead and click run. Oh, hog3 is not found. Can anybody see why hog3 is not found in my code? So I look at that, I'm like, what's R talking about? All right, well, hog2 is spelled HOG2 and hog3. Oh, so hog2 is lowercase, but hog3 has an uppercase H. Great. R is a coding system. It means it's like a very black and white engineer. You can't, there's no joking, there's no assumptions, right? It's all just exactly what you type in. So I changed it to an uppercase and let's run it. Error and margin is missing with no default. Did I not type it in properly? Let's try this. Margin should be like this. There we go. Yep. See how it got mad at me? All right. So margin has to be uppercase or it doesn't recognize it. All right, let's try again. There we go. Yay. Now, maybe you're thinking this is so much work. Yeah, I don't necessarily run mean, median, sometimes I do sums and whatnot, but it just depends on what you're doing in your data and how confident you are. Also, this is the first time you're typing in bigger stuff. I have a sheet, like multiple sheets actually, where I have the code already written out. And so I just copy and paste it and slap it into R so I don't have to worry about making goofy mistakes. Like hog3, that's the data set. So I have to write that in every time. But things like margin or fun or whatever, like I already have all that stuff. So it just, as you work in it more, you'll have these things set aside for yourself. All right, so you should have 8, 7, and 11 as upper, mid, and lower. Cool. So now we can try, don't forget this NARM is the parameter to be used. Let's see, when you specify margin equals 2 right here, you get the function applied to the 2 columns. If you specified margin equals 1, you would be doing it for the rows. Okay, so margin equals 2 is to specify to look at the columns, so up and down. Margin equals 1 is to specify for rows. Now, you're probably not going to remember that. I don't usually remember things like that, but it's a note that you could write for yourself. All right. The tapply command works on data that are in the scientific recording layout, such as the hog2 example. So in that case, there was a response variable, which was count. So let me show you here, right? Response variable is count, and the predictor variable is site. All right. So in order to use the apply command, we need a specific response variable as an index. So in other words, like a grouping predictor variable. However, when you try this in the data, you get an error, okay? So let me show you what happens. I'm going to go ahead and type in the code. So tapply, it'll pop up, sure. We're going to write count index equals site, comma, function fun. You can do this, fun equals median. So this is telling it to apply the count, which variable? The count is our response variable, and the site is our predictor variable. So that's what we're indexing, and the function is to find the median. All right. Oops, I don't want that because that's gonna mess up my code a little bit. All right, so I click run and the object of site is not found. Okay, so the issue is that the variables count and site are contained inside this hog2 data set. It means that they're not really visible to R, all right? So there's three ways that we can figure it out. You can prepend the data name and add a $ to it if you want. So see where it says count right here? I did this up above, so I'm gonna write hog2 $. And then it tells R to look in hog2 for this. So then when I hit run, really? Oh, I have to do hog2 site also. Oops. Hog2 site. So it tells it to look in there. So then I click run, and there we go. So then we get the answer. So instead of just hoping that it knows count site, you have to actually tell it. So if I wanted it to look at a different data set, say BD or hog3 or something like that, okay? You can also subdivide the data using using the $. The other way you can do it is using attach, which is a different command. And you don't have to do any one kind of way. I'm just trying to show you the different ways. So hog2, okay, attach hog2 first. Then I want to run my tapply. So I'm going to copy and paste and take this back out. So I'm going to show you how it works without the hog2 $. So first I ran attach, and then I'm going to run this, and now it gives me the answer. So basically it allows R to see inside of your data. So if you don't want to have to write hog2 $ for every command when you're working, say you're doing a whole bunch of stuff, you just run attach first, and it automatically tells R, hey, R, this is what I'm looking at. Okay, stop giving me the error sign. Okay, how's everybody doing? Doing all right? You can also use tapply to separate or for two different kinds of data that are separate from themselves. There are a bunch of summary commands like aggregate. It allows you to use the function on a response variable as long as it's grouped by a predictor variable. You can do response to predictor. You can specify where the data is found using attach or with. All right, so let me show you. We did aggregate. Okay, so I'm going to do the next one, show you the aggregate command or aggregate. It's up to you, however you think it's best. Okay, we're going to write count, and it's a little wiggle sign count to site, all right, comma, data equals hog2, data equals hog2, and the function is median. So we're still just looking for the median. All right. So this is similar to apply up here, right? But we are using count and site as a response and predictor variable. So I'm going to write to myself response squiggly line predictor variables. This is going to be important. If you're not sure why yet, it's okay. This is why it's introductory to stats. But response variables and predictor variables are really different. It has to do with the X and Y, and we will talk more about this. But for right now, just make yourself a note, okay? It's important to make notes when you're doing code so that you don't forget. So what was attached? This tells R where to look ahead of time. Okay, you can write yourself a note like that, and that's the way to go through it. All right, now we also have, let's see, what else does it want us to look at? Oh, object not found, we did that one. You can slice up a data object. So data, money sign dot name. This really only extracts columns from that particular data frame that you're looking at. If you use row and column, it accesses all the parts of an object. So the money sign is really straightforward. You simply use the name of the data and then the money sign and whichever column you want to work on it, right? Like I said up here, hog2 count, right? So it's telling R to look at hog2 and this column of count. The other ways to do this are to use the row and column. So I'm going to come in here and let's see. Let me make sure I'm doing this right. If we want to look at different pieces of it. So what's called the data frame is this. This is the data frame, which means, and this is also the data frame. This is also the data frame. Okay, so anytime I use the word data frame, I'm just talking about the data. Let's see. The square brackets work with more or less any sort of data object. If you have a single sample, like a single row of numbers or a text, it's called a vector. You can specify a single item in the brackets. If you have a two-dimensional object, you use rows and columns. So I'm going to show you, and let's use the Beatles data for that. So I'm going to write BD and hit run. We already did this once, but let's do it again. All right, so we see this tibble up here. Now I am going to put the square brackets, and I'm going to write, oh, no, I want the square brackets, 1, and I'm going to click run. Oh, error unexpected. Oh, it doesn't like that. Rows, columns. Let's try this. Rows. It doesn't like the brackets very much. Let's try this. BD. Oh, that's why. 1:5. So what I'm asking for is the first 5 elements. Oh, can't subset columns past the end. Locations 2, 3, 4, and 5 don't exist. 2, 3, 4, and 5 right there. Running last trace. So something funky. I probably did something goofy in my data. Let's try again. So I want to BD square bracket 1, 5. Run. Doesn't like this very much. Let's see if anybody else is having this issue. BD 18 to 14. Well, it doesn't like this very much. There's only one column. Oh, that's because it's doing, it should do is two-dimensional. You can try log3 then. 2. Let's try that. Okay, something's wrong with my R, so I'm gonna delete this, save it. And we're gonna skip this part because I don't want it to confuse all of you. So just don't worry about it for right now. We can talk more about this for slicing up data later. We talked about averages and distribution in the lecture. I do want to go over how to make a histogram in R, and then I think that would be it. So let me get to that page here. So make a histogram. So make a histogram. You all should have made a histogram in Excel. If you got any feedback from me, make sure you read it and go back and take some time. The analysis tool pack tends to really help making better graphs in Excel. All right, so in R, we're going to use the histogram function, which is HIST. Then you type in your data, so BD. Then I'm going to run it. Now this will be fun. Oh, X must be numeric. Okay. Why isn't it reading my BD data? So something's up with my BD data. So I'm going to go back up here and I'm going to run this again. All right. And then I'm going to go back down here and see if X must be numeric histogram. Oh, that's right. It's not BD, it's size. We did this last time. Okay, size. All right, let's try. Run. No, it's not a capital S, it's a lowercase s. Do we have to do BD money sign size? Must be numeric. They are numeric. If yours is working, awesome. I'm going to pause real quick and see if I can fix this and not take up too much time. All right, I fixed it. Stand by. So, because BD is the name of the file, but size is the name of the column, I have to use that, right? So, just took me a second. So, making a histogram. You type in histogram BD $size. You hit run, and over here on the right, you get this nice histogram. Just to say this really quick, I will teach you how to fix all of these, but do not turn in, I mean, for now it's fine, but say on a paper or something down the road, you need to change the title and whatnot, and I will show you how to do all of those things down the road. But for right now, if you made your histogram, you're going to export it. So you click on export, you can save it as an image, save it as a PDF, or copy it to the clipboard. And then you can, put it on your desktop and then slap it onto your Word document. All right, you're going to need to do that for your work today. All right, so please grab your histogram and put it on your Word document. All right, so now we did a histogram. Cool, pretty fast, right? If you want to do some other cool plots, we can make a density plot. So density function here. And since I know that this is what I want, I know this is short right now, but when you have huge functions, I've just gotten used to copying and pasting the same thing. So density. All right, so now we have this cool density plot down here, and that gives us the information first. So now we're going to plot it. So plot density. And you want to put in BD size, copy, make sure you put it in the right one, paste. Okay, and run. And now it gives me a plot. Cool, huh? I want you to go ahead and export this as well. All right, so we have a histogram, we have a density plot. Let's change our histogram color. I want to teach you how to do a couple things like that. And the y-axis is named frequency, so we're going to redraw it and make sure the y-axis says sum instead of frequency. All right, so we're going to type in, we're going to go back to our histogram, so you can just grab this code, copy it, and paste it here. All right, so we have that histogram, cool. Run it, so it brings it back up. You can also just go back and forth like this here. See these little, but want to do, is it the same one? Yeah, okay. All right, so we have a histogram of BD size. We want to change the y-axis to from frequency to say density. So we're going to type in histogram BD money sign size. Okay, that tells us where to look, right? Frequency equals false because we don't want it to say that. And we want the color, or COL, to equal light blue. Cool. All right, go ahead and run that. Ooh, so you'll see now my y-axis says density, and my color is blue. Pretty nice, right? So let's add a density plot line to this. So we're going to write lines, and you are going to put density and BD sets like that. All right, so BD money sign size. Run it. And now you have a nice density line. Cool, huh? So the lines command adds lines, and density command calculates the coordinates from your data. So this is pretty cool, right? So let's go ahead and save that. I know this is a long tutorial, and if you need to take a break, just hit pause. All right. Make sure you export your blue histogram with your density line. All right. Let's see. So now we're going to look at ranges. You can do range in Excel. You can also do range in R. The minimum, the maximum, maximum minus minimum. The codes for that are max. BD, money sign, size. Let's do that one. So I'm gonna put in range, just so we know what we're working on. Okay. So that's 36 minimum, BD, money sign, size. Okay, that's 16. You can also do things like max. Actually, here, I'm gonna do this because that way I don't mess it up. Max, copy, paste, minus, minimum, copy, paste. Okay. Run that one, and you get 20. So go ahead and copy these three answers right here and put them, just right click, copy, and paste them into your Word document under like range, working on range in R or something. You'll need the range when you get to writing in descriptive data. So I'm just trying to go through all of this. That's why you should be saving this as you go. So range, BD, size. All right, run that one. So now you have the range from 16 to 36. This gives you the range of numbers. If you notice up here, this density graph, it gave you the quartile values. All right, so we're going to do some quartiles. This is important because you can make leaf and stem plots with these. I know that sounds a little funny, but that's what we can do. All right, so let's see. I want you to just make sure we're doing this. Okay, I want you to go ahead and type in summary. So we're going to do working on quartiles, summary of BD. Okay, so now you have your minimum, maximum, median. There we go. So that's your whole data summary right there. Pretty cool. You can do quantile of BD. All right, run that one. Error. Oops, oh, that's right. For quantile, because it needs a numeric thing, you have to do BD size. It needs the name of the column. All right, and then we get our percentages. So 0% of those are at 16, half of them are at 26. Okay, makes sense. We did the summary command. It's a general command and makes a little bit different report, as you can see. In the quantile, it's a much more specialized command. It's made for producing quantiles, and you can see that it's presented after the summary command. You can see that you have 5 different quantiles here, right? 0, 25, 50, 75, and 100. To get a specific type, you can type in quantile BD, comma 0.75. All right, and run. Oops. BD, money sign, size, and run. Okay, and it gives you the answer here, which is 29. All right, it's the same answer that you get up here. So, your data will be different each time. So the things that you're going to change are going to be the name, BD, size, right? So that's just the data that we're working on. In order to make a box plot, which is really helpful, box plot BD, go ahead and run that. I want you to export this and show me that you made a box plot. All right. It's kind of sparse right now, so you're going to need to add axis and titles so that it looks better. It's important to do that because otherwise it looks real funky, right? That's just a box plot. I have no idea what that means, and I'll probably forget what it means too, so you'll also need to remember how to do that. I want you to make a box and whisker plot, and on the y-axis, size in millimeters, and on the x-axis, I want you to write beetle sample. That will be part of your hunt and find. So Google, how do I add X and Y axis labels on a box plot. All right, I want you to go ahead and do that. Look it up, hit pause if you need to, and then add it in. All right. All right, hopefully you found it. Share my screen again. Oops, our studio. So how do we do this? We want to label our X and Y axis. So box plot. Oops, gotta start typing in the right place, Dorothy. Box plot. Cool. I want to do BD and then X lab, which is the X axis label. So X is the bottom one. So what's down here? We're going to write beetle sample. So quotation marks, beetle space sample. Then I want Y lab, which is the Y axis label. And I'm going to do quotation marks and we're going to write size in millimeters. All right, and then I'm going to run it. Oops, come back down here. Run it. Could not find X lab equals Y lab equals. Is that it? No, doesn't like that one either. Hold on. So I'm going to play with this. Y lab. Oh, it's ggplot. So maybe ggplot is not in. I thought we added ggplot earlier. Let's see. Let's make sure the library is good. So I'm going to run the library. Then I'm going to go back down here. And it doesn't like my stuff here. We need to put a parentheses right there. Okay. And there's one too many parentheses, so I fixed it. Let's try to run it again. There we go. Okay. Beetle sample. Oops, we need to fix this part. Get rid of the equal sign and run it again. What happened? Put the equal signs in there and then it works. Look at that. All right, so just have to play around with it. I do not always remember how to do this 100% of the time. I have to look things up all the time. So I don't know anyone that, well, I do know some people because they have like a, what is that called, an eidetic memory, but I'm not one of those people. All right, this kind of stuff is hard for me. So I always have to look for help. So that's why I'm trying to teach you all these little tricky things. So I'm at the end, I'm going to label this. How to label your X and Y axis. Okay, because I'm definitely going to need this down the road. So once you've labeled your X and Y axis, I want you to grab this and export it, please. You could also change the color. You type in like comma color equals green. Let me try that. All right, watch. Run. And I can make it green. Okay. So you can try a color if you want and do that too. This is really great when you have multiple box plots so that people can see different colors. Green obviously is not the best choice because red and green are hard to see for folks. So let's try blue. Okay, and run it. There's a blue one. All right, so now you've learned how to label them, label the axis, and change the color. Cool, let's hit save. Go ahead and export that and put it on your Word document. Now we're going to start working on some standard deviation, doing standard deviation in R. We use this with a simple command. So let's do standard deviation. Who remembers what we use standard deviation for versus sample error or simple error rather? Think about in the lecture. I think I asked you this question. So go back and write it down. That's something you probably need to remember down the road. All right, so standard deviation. SD, then we want to, oops, is it SDEV? No, that's SD for R. Okay. And then we want to do BD and run it. Cannot be coerced as a double. Let's see. BD size. Try that. Run. Yep, there we go. So we have to tell it to, because it's a numerical equation, we have to tell it to talk to the numbers and not just the whole thing. So 5.04, yep, there we go. You can also calculate the variance doing this. So VAR, variance, BD, size. Go ahead and run it. And now you have the variance. Okay, so the properties of standard deviation shows a lot of different things, right? We talked about this a little bit yesterday, or maybe you watched the lecture earlier in the day. We have a lot of different data in here that I can play around with. Let's go ahead and test for normality, because I talked about that a lot, and that's something that you're going to want to play around with when you have your own data, and this is something that you're going to want to do on your final data sample that we do for this class, since I'm not giving you an exam. Let's see. So we want to write out that we are going to test for normality. All right, so I'm writing myself a lot of notes. All right, so the Shapiro-Wilks test for normality in R. So we're going to write Shapiro dot test. Oops, did it start to come up? Cool. When it does that, I just click on it. It's easier. And then we're going to write in BD. That's our data set that we've been playing with. And we're going to run it. It's numeric. So we have to write BD, right? $ size. And run it. So now we have the normality test. So you can see that the results are not significant. And what that means is right down here. So that's our data that we looked at. The p-value is 0.9. So the only time that it's significant, meaning that the data are not significantly, so this means the data are not significantly different from a normal distribution. So that means that this data set is normal, all right? Now, if you got a p-value less than 0.05, it would mean that the data is significantly different from normal. So the test for normality, the hypothesis is that the data is normal. So the alternate hypothesis is that the data is not normal, right? So because you get a p-value, just maybe make yourself a note. P-value greater than 0.05. So I'm going to write this up here. P-value greater than 0.05 means data is normal. Okay, does that help? Less than 0.05 is not normal. So that means it does not have a normal distribution. So we talked about that bell curve. Okay. All right. So now let me get rid of that. Okay. So we're going to talk about normality testing, distribution type, now standard error. Let's see. I think we might have some data for standard error. Can play around with that, and some confidence intervals that we talked about in the lecture as well. So let me just get to the right page here. You can also take the square root of data. You can take the square of data. Let's see. We're going to want to go ahead and upload. I think we're going to want to upload this other data set. Yep. So the other one we want is leaves. It's an Excel sheet, so import your data. You will have it on Canvas. I'm going to grab it from where I have it. And here, leaves. I'm going to name it LF Okay, LF. As you can see, it's a much bigger data set. Okay, so I'm gonna grab my code, copy, and import it. Okay, now we are working with the new data. And I'm going to paste. Oops, if I can spell right. Okay, I'm going to read that Excel sheet and view it. There we go. So now I have my leaf data. All right. Okay, so we're going to work on a couple of different things. We're going to look at generating numbers. We're going to look at plotting things, all right, and plotting what's called a running mean. So it's just another thing to try and do, all right? Just a little exercise that I want you to play with this. So you can do this in Excel as well, but I'm going to teach you how to do it in R today. You're welcome to try it in Excel. Just email me if you want me to send you how to do it, or you can just Google it, okay? All right, so if we want to run a means, you can easily calculate this. Excel provides you with the average function, and it can be pressed into service really simply. You can use a range of cells and copy and paste it. You can use the average, and then that gives you the mean, right? So you can plot this as well in Excel, but I'm going to show you how to chart this in R. So first, we want to use the mean, SD, and histogram commands. There's not really a built-in function to determine the running mean, but there are several functions that relate to it, and one of them is called cum sum, and this determines the cumulative sum of vector values. So we're going to write cum sum lf, okay, and we are going to run it. Okay, it doesn't like that. Too many numeric values, so we're probably going to have to do data leaf sizes. What is this? Column 2, column 3. So this is a problem in Excel. So we're going to have to clean up this sheet. So I'm glad I showed you. So I'm going to cancel out this sheet. I'm going to open it up. So you should have downloaded it. Go ahead and open up your leaf sheet. Let me find mine here. Okay, I'm going to open it up. I am going to erase this completely because it's dumb. I'm going to copy this table, click on copy, and I'm going to paste it in the corner. And then I'm going to delete all this extra stuff. Delete, delete. Okay, if this bothers you, you can make it smaller. All right, but now what this does, the lines don't matter, but the numbers do. Okay, so now I'm going to click save. So now when I upload this into R, it's just going to read S1, S2, S3, and then the numbers. All right. Otherwise, it was reading all this other weird stuff that shouldn't have been in there. So good lesson on the fly. You have to check your Excel sheet before you upload it. All right. So now I'm going to go back to R. I'm going to import my data set again. I'm going to look for leaves again. Go ahead and grab yours. Leaves. Okay, I'm going to make it say LF. Now you can see at the top that everything is, S1, S2. This is double. If you need to change this, character, numeric, date, for right now, double is fine. Okay, so copy and paste your code. Copy, it should be the same unless you moved it around. Import it. Go ahead and paste it here and run your data. Run, 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 view. There's my data. Cool. Now I'm going to do a cumulative sum. And now it gives me this really cool chart. Awesome, right? So you get all these fun numbers in here. So now we want to run a sequence. So you're going to divide. So say you wanted to divide the first value of 35 by 1. okay, or 34, I guess it is, by 1. And you divide the second number, you're just doing weird division numbers, okay, cumulative sum. So it's called a running mean, okay? So now we're gonna do, you know what? I don't think you're ever gonna use this. Not anytime soon. Just stop. If you want to do this and you want me to send you this piece of the tutorial, you're welcome to. But otherwise, I don't think I've ever done this, even in papers. And so I'm not going to ask you to do this because it seems silly. You don't need to plot the running mean of anything. Okay, this is an intro class, and that is an extended stuff. All right, so that is the end of, go ahead and click save. I'm going to stop sharing my screen. That is the end of chapter 4's R tutorial. Deep breath. Whew. Remember, there's no questions in here, so you can pause, rewind, use it as much as you need to. Make sure you can also download these videos if you want to save them for later, like down the road when you're actually doing stats, and you can always come and ask me questions. All right.